Hello and welcome to a new processing tutorial. This one is for the Galaxy's M81 and M82. I actually took this testing my new Stellar Drive mount along with a new guiding system. Got an ASCAR M54 OAG and a ZW0220 guide cam, and all those things together are working really well, and I've written reviews for them up on my urban astrophotography website, so I recommend you check that out. And during those tests, I had just one clear night and I gathered about 6 hours of data, and that's all gone into this image. It's a broadband image, and I use an Optolong L-Quad Enhance because I find that to be quite good at helping with the light pollution in my city centre location. Now, because we're not combining different filters, like there's no L Ultimate or ASCAR E2 or anything like that, it makes the processing a little bit simpler for this. So I don't need to do any kind of alignment or anything. Also, I found that the mount is performing so well. The guiding was between like 0.3 to 0.4 RMS, which means that I don't actually need to bin this data. So I don't need to run integer resample, which is a bit of a change for me. So that's quite exciting. If you want to find out more about that, again, check out urbanastrophotography.com. So the first step I'm actually going to do, as usual, let's make a clone in case we need to go back to change anything. And then we want to run image solver. We're not going to see any visible difference, but Image Solver is going to embed lots of information about the picture within PixInsight's memory so that PixInsight can run different functions properly, things that we'll do later. Once that's done, we need to sort out the gradients in our image. We get bad gradients, particularly when we're imaging from a city, because we've got lots of sources of light pollution. Now, the best way I found to deal with gradients is a free SETI Astro plugin called Automatic DBE, Automatic Dynamic Background Extraction. I'm going to leave all this on the defaults and just click execute, leave it going for just a moment, and I just find it does a remarkably good job at dealing with gradients. Once it's done, it's going to spit out two images, which both look black to start with, but that's because we need to run an unlinked screen transfer function to see them. First image is the background that it's removed. Quite interesting, but we don't need that. We can close it. This is the one that we want. Let's run that. This is our main image with the background gradients taken out. So we can remove the original, and here we've got this one. Next step is to run Blur Exterminator. Now, you could just leave everything on the defaults. I do an extra step, though, to calculate the PSF. PSF is the point spread function, so it's kind of a measure of how blurry the picture is. I find that if I leave it on automatic PSF, it does an okay job, but I get a better result if I calculate the PSF myself through a little precursor step with render and a separate plugin that you can download for free called PSF Image. I'm going to click evaluate, give it just a moment, and we'll see what numbers it comes up with. All right, we're looking at the two full width half maximum values here. They're kind of a measure of the star. These numbers are actually really close together, closer than they normally are for my images, and this is an indication that my mount and its guiding were performing so well that the stars are nice and tight. What we want is between those two, so let's say 2.93. Yeah, let's go with that. 2.93 is a number we want to remember. We're going to click OK. And then here, 2.93. That's what we've calculated. Now let's run that. It'll take a few moments, and we won't see much visible difference when we're zoomed out like this. But if you were to do a zoomed in comparison, you'd see that Blur Exterminator does sharpen things up a little bit. All right, now that's done, we can close that. And we're going to sort out the colors, do a bit of color calibration next. A useful first step is another SETI Astro script called find background, and this is just going to find a blank bit of background to our image. That's going to be used as a reference point for the next color calibration step. Okay, let's load up SPCC. This is going to sort out our colors. We're in broadband data here, so we don't need to click narrowband filters mode, so that keeps it even easier. Yes, we want background neutralization based on the region of interest, which is that background area that was just calculated. Select that and then run, and it shouldn't take too long. We should get a nice graph out of it, and then a an image where the colours are a lot better. There we go. And we can right click and delete that background because we don't need that anymore. Next step is to stretch the data from linear to non-linear. There are a few different ways to do this. I'm actually finding the most luck with PixInsight's native function here, which is, what's it called? Multi-scale adaptive stretch. So I'm going to load that up and then click on the little circle. It's going to give a real-time preview. And to start with, it will probably be completely white because we're doing a preview on an image that already has this STF stretch on it. So to take that stretch off, we make sure the main image is highlighted, and then we go to the top here. You can see there's the monitor with a little X in it, reset screen transfer function. So I'm going to click that, book, and then it's applying that preview properly. Now I'm finding actually that the defaults in multi-scale adaptive stretch are pretty good. So feel free to tweak all these, but for now I'm just going to keep it at the defaults and then click apply. And then hopefully we have our stretched image. And we know for sure it's stretched because we can see all the detail in it, and we don't have the green bar that's compare. Green bar means we've applied that STF, no green bar. So this is all good. In fact, let's change that to MAS because that's the last thing that we did. Make a clone of that and put it over there. Okay, looking good. It is quite noisy though. Not entirely unexpected because it is only 6 hours from a Lake city. Let's run a bit of noise exterminator though, shall we? We don't want it to be too much though. I find that 0.6 for noisy images is pretty good. Any more and it starts to kind of blur the data a bit too much. But give it a go for yourself, do some tests. But for me, 0.6 is normally a good point for like dealing with quite a lot of noise. All right, I think that's cleaned it up quite nicely. But we haven't taken out all the noise, but that's okay. Our brains interpret some noise as sharpness. If you get rid of all the noise, then it just looks a bit plasticky. Next step, we want to separate out the stars and the galaxies from the background so we can work on those separately. So I'm going to make a clone of that and then run StarNet 2 just to take out the stars from there. This is a good precursor step to the main one, which is called screen stars. Right, so then we need to go to Script, Utilities, Screen Stars. When we're doing star removal. So the star review is L-Quad Mass. And the star less view is L-Quad Mass Clone 1. And then we click on the tick, and then we should get our stars out. Now I had a comment on a previous video which was about what you get stars. You can create a star mask if you click the create star mask in StarNet 2. So why bother doing all this step? If you use screen stars, the stars that you get will be of a higher quality than if you just click on there using StarNet. All right, so we have our stars, all looking good. Maybe there's still a little bit of green in them, I think. We don't have any green stars, so I am just going to use SCNR to sort that out. And then the stars we'll put up here, and we'll need those near the end. Let's just minimize that because this is actually the one that we want. Let's call it L-Quad Starless. Make a clone in case we mess anything up. Here we go. This is what we're working on now. So I think that a good next step... Actually, let's do SCNR, take the green out. Yeah, I think that's improved the background just a little bit. I know SCNR is quite a blunt tool, but we have color calibrated already, and there isn't really any green in this image, so I think it's fine to use in this circumstance. All right, let's use curves transformation now, just to darken the background a bit and bring our galaxies out a bit. And perhaps a mask is called for at this point. So what I want to do is select just the galaxies so we can work on them, and just the background so we can work on that separately. So we do that using range selection. And I'm playing about with these until we've got just the galaxies selected. Maybe the galaxies and any other bright object. There we go, that'll do. Click OK for that. And there we have a mask. So I'm going to put that over there to apply it. But I don't want to see it applied, so I'm going to click on the little magnifying glass up there. And then I always forget which one is applied. Is it the galaxies or is it the background? Well, let's just go to curves transformation and we'll see. Okay, so the one I've selected here is for the galaxies, isn't it? So shall we give them a little boost? To know where to move the graph in curves transformation, if I just click and hold on the galaxy, I get some lines over on curves transformation, which kind of show where most of the data is. So I'm going to give it a little boost there. Oh no, messed that up. Just a little boost. And maybe run a little bit of unsharp mask. Default there is too much. Just a little bit to sharpen it. Say 0.35. Run that. And then I want to darken the background, so I want to invert that mask, which I can do with this button here. Click. And then let's go back to our curves transformation. And then darken the background. There we go. Not so much that you get a real contrast between the galaxy and the background, but let's just go with that for now. Then we might want to clean up some of these blobs. Yeah, let's do that. Let's minimize the mask in case we need it again. Take the mask off here. And then I'm going to use Setiastro script called Blemish Blaster. And I'm going to shift click around any blobs that are artifacts left over from star removal. But be careful not to take out anything that's an actual feature. Like this one here is like a satellite, a dwarf galaxy to M81, so we don't want to take that out. All right, I clicked Auto SDF to increase the contrast. Going to apply that to the main image, and then exit. Oh, did it do it? I think maybe I clicked the wrong thing. Let me try that again. Execute. I think I missed that one, didn't I? Right, then apply to main image, and that should do it. Okay, that's cleaned up the background a little bit. Now, be fine to play about with this image a bit more, but to keep things speedy, I think now I'm going to put the stars back in. So we want our utilities and screen stars. And now we're doing star replacement. So the star review is the star review is stars. Oh, sorry. The starless view is L-Quad starless. And the stars view is stars. And this gives us a preview of what it's going to look like. So we'll click tick on that. There we go. And this is pretty much done. Could play about with it some more, do some more different tweaks. But for now, I think this is good enough. And I don't need to do my integer resample to upscale at the end because I didn't bin 2 at the beginning. So a little bit faster. Great. Thank you very much. I hope that was useful. And I'll see you next time for another video.